Hello everybody, I'm Mohit and my teammates are Tejas and Gopal. We are from EEE Department MSRIT. Today we are going to discuss about online gas monitoring for increased transformer protection, which is an IEEE paper from the year 2017, published by Michael Sad and Etienne Enius from Brampton, Canada. Well, transformers are defined as the electrical devices which is used for transferring power using principal mutual induction and hence plays a vital role in power distribution system. A breakdown of this kind of transformer will lead to the huge loss to the whole economy. Hence, it is important to know about how well we can protect our given transformer. Well, we know transformer requires insulation. These insulation can be of two types. One is solid insulation and liquid insulation. Liquid insulation is nothing but transformer is filled with oils. Generally mineral oil or even ester oil also is being used nowadays. The main function of these type of oils is to dissipate the heat generated inside the transformer from the active component of the transformer to the outside of the component so that it not damages the other components of the transformer. Transformer oil is made up of atoms and molecules, specifically carbon and hydrogen atoms. These atoms are bonded together through a chemical bond. Whenever there is any fault in a given transformer, there is a heat is generated. This heat is sufficient for breakdown of these bonds and form byproducts. These byproducts can be combustible or non-combustible gases. Coming to the next slide, this slide tells about the actual formed gases in a given power transformers. The gases like hydrogen, carbon monoxide, acetylene, ethene, methane are formed, and you can also see their chemical structure where the atoms are bonded with single or double bond. Well, before going to gas monitoring system, I like to tell why do you have to monitor these transformers. According to a study, in a given substation, around 0.53% of transformer fails annually. That means for a given 1000 transformers, there are 5 to 6 transformers fails every year. So it's really important to know which among those five transformers fails. So in order to reduce the power interruption. Coming to the gas monitoring system, it is a simple system where sensors are installed into the transformer tank, which sends several data every day about the condition of the transformer oil, through which a trend can be plotted, which tells about the condition of the transformer and even the health of the transformer. Basically, there are two types of transformers. One is single gas devices and multi-gas devices. Coming to single gas devices. Single gas devices are also called as single gas sensors. They usually measure the hydrogen levels in the transformer oil. We know that the hydrogen is the lightest gas when compared to the other gases. So it is easier to break down this hydrogen molecule even in lesser temperature. The generation of hydrogen gas can indicate the most major faults including partial discharge, thermal degradation and arcing. Well, most of these sensors makes an alarm whenever the concentration of hydrogen exceeds than the certain level inside the transformer oil. The main advantages of single gas devices are it provides warning at relatively low prices and it is easier to install. The disadvantages regarding single gas devices are still the lab results are must as these results may be inaccurate and impractical. Coming to multiple gas devices. Multiple gas devices are also called as multi-gas sensors. These sensors can measure the different gases, not just the hydrogen gas in the transformer oil. They can measure up to 9 different gases inside the transformer. They are more accurate and they doesn't require any lab analysis and they are not time consuming and provide faster information on the health of the transformer. Coming to the disadvantages of these multiple gas sensors are maintenance of these sensors are required and they are higher cost and have increased installation time. The further PPT presentation is continued by Gopal.
Choosing right type of sensor. It measures the gas concentration in the transformer oil and detect or identify the transformer faults. It plays a major role in monitoring system. Some factors could be considered while selecting the sensor. They are importance of asset, monitoring cost, health of the transformer monitor, and added benefits. Importance of asset. The risk of having a power outage due to the transformer failure must be evaluated. It is a valuable tool to determine the importance of the unit. Many factors can determine the risk of, such as availability of the spare unit, location of the spare, capital loss of the power outage, safety of end users in the event of power outage. For example, if the transformer is providing power to the hospital, then the unit is more important than the other unit. So we have to install multi-gas monitoring device, while single gas monitor device used for this importance unit. Monitoring cost. Monitoring devices are selected at the manufacturing stage of the transformer. These units are installed into the existing transformer, which is more expensive. Multi-gas monitors requires constant and repetitive maintenance that can be expensive depending upon the technology used. For example, sensors that use gas chromatography require gas canisters to be constantly replaced. This future maintenance might be taken into an account. It also depending upon the size and complexity of the design. Monitoring device to a transformer should only account for a small percentage of the overall value of the unit. For example, installing a multi-gas monitoring device on a 1 mA transformer might be expensive transformer itself, so lower value of the transformer assets is essential. A single gas monitoring device which is less expensive. Health of the transformer monitor. If the unit is starting to generate gases at the slow rate, a single gas monitor device could be installed. Monitor would alert only when the hydrogen level exceeds the specified limit. In case multi-gas monitor device installed on the same unit, then each gas formation could be viewed in a real time. It can be determined if the unit is developing a slow monitor faults. Added benefits. If the unit is not easily accessible, the use of the multi-gas monitors would be the better choice. Multi-gas monitors contain powerful processors that are able to program interpretation algorithms. The software uses a gas levels to determine the normal operating range of the transformer, but single gas monitors would not have such softwares. Additional added benefits are quality of service, cost, emergency response.
Let us have a brief look on DGA monitors. In DGA monitors, DGA stands for Dissolved Gas Analysis. These DGA monitors is a kind of sensor which provides us information about the quality of transformer oil. Let us see the need of DGA monitors. Initially, transformer oil will be in its pure form. As we keep on using it, it will get contaminated with the gases. This contaminated oil is allowed to use only up to certain extent of contamination. Beyond that, we can't use. Hence, to overcome this problem, we need DGA monitors. Like other components, there are few qualities to look for while choosing DGA monitors. Also, few challenges must be addressed while installing and operating DGA monitoring system. Let us see it one by one. Installed monitoring device should not harm to the unit. A possibility of oil leakage could occur on some monitoring devices due to sampling methods or installation. Oil leakage can cause environmental issue with significant oil loss. In worst case, the active part could become exposed and cause a major failure. Hence, it should be taken care. The oil samples entering the sensor should be representative of current gas generation of transformer. If the sensor is using stagnant oil, it may give foul result. Hence, proper placement of monitoring device is necessary. Quality of sensor stability is a major factor as it interacts with various chemicals present in the unit. The sensor should not get adversely affected or deteriorate from the oil present in the transformer. Sensor should not be affected by cross sensitivity. Cross sensitivity means sensor's reaction to interfering gases. It means it should sense only the targeted gases. The monitoring equipment should not consume or modify the measured oil sample, as it may have to perform multiple tests
Hence, consuming oil each time may reduce the amount of oil in the unit. System should be able to operate with low maintenance cost. Like other machines, it is also expected to have low maintenance cost. The sensor should have high accuracy of measurement. For a good operating system, it is expected to provide accurate result. Monitors with more than 30% of accuracy should be avoided, as it may provide unreliable results. Many methods have been developed for providing diagnosis regarding condition of the transformer. The most popular methods are reverse ratio method, IEC method, and dual triangle method. Transformer are important and expensive component of electric power system. Failure rate of such transformer is very low, but if it happens, it causes severe property damage and also cause disturbance in electric power supply. By adding monitoring system to the transformer unit, risk of failure can be avoided. Well selected or a good DGA monitor can improve overall reliability of transformer fleet.